Hey guys, welcome back to the channel. In the previous video, we discussed zero shot and few shot prompting. We saw that while few shot prompting can significantly improve a model's performance, it still struggles with tasks that require complex reasoning. This led researchers to ask an important question. What if instead of only providing examples, we also showed the model the reasoning process used to arrive at the answer? After all, when humans are faced with a complex problem, we usually don't just directly jump to the final answer, but we break down the problem into smaller and simpler steps and solve each of them individually and then arrive at a final solution. This idea gave rise to a powerful prompting technique known as chain of thought prompting. In chain of thought prompting, we don't just provide examples. We provide examples along with the step-by-step reasoning required to solve the problem. By explicitly showing the reasoning process, the model learns how to approach complex problems in a structured way rather than attempting to generate the answer immediately. As we can see in the example, first of standard prompting, the model was unable to solve a question which required it to break it down step by step. But if we use chain of thought prompting and broke down the question into simpler parts, it was able to solve the complex problem easily. And as we discussed in our previous video of the few shot prompting limitations, we saw that it was not able to solve a complex problem. But after using chain of thought prompting and giving it a few examples where we broke down the question into simpler steps, the model was able to correctly solve the question which at first it struggled in few shot prompting. That is why chain of thought prompting is very beneficial for tasks which are complex and require them to be broken down into simpler ways. So the question is why chain of thought prompting actually works. The prime reason is for any model solving a simple arithmetic task is much more easier as compared to a complex task. And that's exactly what chain of thought prompting does. It breaks down a complex task into simpler tasks which the model is easily able to solve. Secondly, visibility and debugging. So if a model makes a mistake in suppose an arithmetic step, it is quite visible where the model was unable to solve. And we can take this as an example and help the model improve on that particular part later with better examples. Thirdly, it has been observed by researchers that this is very suitable for tasks which involve logic, maths, or require tracking multiple steps, such as if we toss a coin heads up and it rotates 7 times, what is the final output, whether it's heads or tails? In such kind of tasks, chain of thought prompting has been worked significantly better than other prompting methods. Now, the thing is, in chain of thought prompting, we don't every time explicitly need to provide examples, but also authors have up with a method known as zero shot prompting, where just by adding a prompt, let's think step by step, the model is encouraged to generate its own chain of thought and has been seen to improve the performance. As we can see in this example, we necessarily didn't give any particular examples in the prompt, but just a simple addition of line, let's think step by step, help the model improve its method and it was able to solve the complex problem by breaking it down step by step. So we are here observing the results of the chain of thought paper, where we can clearly see that the chain of thought paper was very successful in solving maths and logical tasks compared to standard prompting. Also, we could observe the improvement in the model was very higher if the model was large model, like it has more number of parameters as compared to a model with lesser number of parameters. The other observations we could make was that the model didn't actually benefit a lot when it was having a lesser number of parameters as compared to a larger number of parameters. Another striking point mentioned by the authors was that a large language model like Palm 540B was able to exceed GPT-3 with only 8 state-of-the-art examples of chain of thought. This only speaks miles about the performance chain of thought prompting can actually bring in our model. So even though chain of thought prompting works pretty well, it still has limitations. Firstly, the outputs which they produce take a lot of time and this causes a lot of latency and cost issues as the number of tokens they generate are longer. Secondly, if there is one single incorrect step, then the entire propagation falls on that particular path and gives an incorrect answer. And thirdly, it's not very effective for small scale models. And also, if there is a simple task like a simple arithmetic operation, it still goes on to its entire reasoning path, resulting in wastage of tokens and time and cost. And that's going to be it from my side for chain of thought prompting. In this video, we learned why few-shot prompting struggles with complex reasoning tasks and how chain of thought prompting introduces intermediate reasoning steps, why it improves performance on tasks such as mathematics and logical reasoning, and some of its key limitations. In the next video, we will explore another prompting methods that is self-consistency. So that is going to be it from my side for this video. Make sure to like, comment and subscribe and help me know where I can improve further. Thank you guys.